Hi, we are Group 2, and we join 玉山人工智慧公开挑战赛. And based on this table, we will introduce our preprocessing data, data engineering, and the model we use, and finally results. DP4 is the dataset which records the debit and credit information of customers. The relationship between the amount and the exchange rate is TX amount times the exchange rate equal to the total amount. We also find that the credit and debit data is normal distribution. Observing the relationship between cross-bank and ATM, we find that those who use cross-bank are all transformed with ATM. Moreover, money laundering is more likely happen in non-cross-bank and non-ATM. For the dataset CCBA, we observe that those who own less asset had lower line of credit, borrow, and spend less money are more likely to be reported as SAR equal 1. We guessed that it's because people who want to do money laundering wouldn't like to take too much effort to get good credits. And they wouldn't trending with lots of money since they don't want to get bank and police attention. In CDTX, we found that those who were reported as SAR equal 1 are more likely to happen in foreign country and with foreign currency. There are lots of missing value extant in data, especially the DP4 data. It totally has millions of missing cells. Here are preprocessing we done on customer info file. What was mentioned is race rank because we think normalization of this feature isn't meaningful, so in order to make the weight of race rank not too big, we choose the one hot encoding. For the DP4 file, we firstly combine all transaction records based on each custom ID of the same day together. Therefore, we obtain new DP4 with the same row as customer info file. Then, focusing on alert date, we combine all rows in the new DP4 file, which are listed before each of the alert date together as one new row for each alert key. The detailed processes are also explained in this page. Among this process, we not only transform the original feature in the file, but also create some features that we think are important. For example, as long as the amount of the one transaction is higher than 500,000, the system will report that star flag as 1 according to the law. Therefore, we think the maximum amount of a single transaction is also crucial and add some feature into new DP file. And finally, for our numeral feature, we do data normalization. We choose logist regression and decision tree initial before we divide into data set because we think these two models are the most common things and base ones when doing data mining. After understanding data set in order to alleviate the problems of unbalanced data, we have tried SVM, get the outcome wasn't better. Then after listening and learning from other teams' presentation, we found that LSTM often has good results, so we have also tried it. As for our attributes, because a lot of paper, articles, and a book we read which focus on teaching how to anti-money laundering or recommend this model. And this model is truly the best performance one among all models we use.
Resulting from attributes, we get our best score, which is around 0.01. We normalize all the features in DP4 dataset as well as the customer info. And we combine all transaction data of each day. Also, we lower the learning rate and increase the trees to increase the accuracy. And here is our reference.